The Moon, our natural satellite, has been a source of fascination and inspiration for human beings forever. In addition to its natural beauty, the Moon has significantly impacted life on Earth, from tidal regulation to influencing climate and axial stability. The Moon has influenced various terrestrial processes. But what will the Moon look like in 3.8 billion years? Let's find out. To understand what the Moon will look like in 3.8 billion years from now, it is necessary first to understand some of its characteristics and influence on Earth. The Moon is the fifth largest satellite in the solar system, and its size in relation to the Earth is unique. The Moon is about a quarter the size of Earth, making it the largest satellite relative to its planet. Also, it's very ancient, at around 4.5 billion years old, making it one of the oldest objects in our solar system. One of the essential features of the Moon is its influence on the tides. The Moon's gravitational pull on Earth causes rising tides, which in turn impact marine life and coastal erosion. The tides would be much smaller and less pronounced without the Moon's influence. In addition to its influence on the tides, the Moon is also responsible for the axial stability of the Earth. The tilt of the Earth's axis is responsible for the distribution of sunlight in different regions of the planet, and the gravitational pull of the Moon maintains this tilt. Without the Moon, the tilt of the Earth's axis would be much more variable, which would significantly impact the climate and life. However, the Moon has not always been the same distance from the Earth. Since its formation, the Moon has gradually moved away at about 1.5 inches per year. How do we find out that the Moon is moving away? The idea that the Moon is moving away from Earth is based on scientific evidence and detailed astronomical observations made over several decades. The French mathematician Edmond Halley made the first observation that suggested that the Moon was moving away from Earth in the 18th century. However, the definitive confirmation that the Moon is moving away from Earth came thanks to the technology of space missions. In 1959, the Soviet Luna 3 probe took the first photographs of the far side of the Moon, making it possible to measure the Moon's position around Earth accurately. Later in the 1960s, NASA sent the Apollo mission to the Moon, which made it possible to make precise measurements of the distance between the Earth and the Moon. Additionally, astronauts installed reflectors on the lunar surface, which allow scientists to measure the exact distance between Earth and the Moon using lasers from Earth. These precise measurements of the distance between the Earth and the Moon revealed that the Moon is moving away from Earth at approximately 3.8 centimeters per year. This discovery surprised scientists, since it had not been anticipated in previous theories about the Moon and its orbit around the Earth. Since then, scientists have made numerous measurements and calculations to understand better why the Moon is moving away from Earth and how this will affect our planet in the future. Thanks to these observations and calculations, we now completely understand the relationship between the Moon and Earth and how this relationship is evolving. The Moon is moving away from Earth due to energy transfer between both celestial bodies. The gravitational force that the Earth exerts on the Moon creates a tide on the Moon's surface, which in turn exerts a tidal force on the Earth. This tidal force causes the Earth's rotation to slow down, increasing the length of the Earth's day. However, the increase in the length of the Earth's day means that the Moon's tidal force on Earth is decreasing, which in turn decreases the Moon's orbital velocity. As a result, the Moon is gradually moving away from Earth at approximately 3.8 centimeters per year. This energy transfer process is known as tidal braking, and it occurs because the gravitational force exerted by the Moon on Earth is not uniform. The gravitational force is most potent on the side of Earth closest to the Moon, causing a bulge in the ocean water and a high tide on that side of Earth. At the same time, on the opposite side of the Earth, the gravitational force is weaker, which causes a low tide. As the Earth rotates on its axis, these tides change position and create friction between the Earth's surface and the ocean water, causing the Earth's rotation to slow down. As a result, the length of the Earth's day increases, which causes the Moon's tidal force on Earth to decrease, and the Moon gradually moves away from Earth. This process will continue for the foreseeable future and the moon will constantly recede from Earth. What will the moon look like in 3.8 billion years? Since the moon is moving away from Earth, it will likely appear much smaller in the sky. About a billion years from now, the moon will be too small to eclipse the sun completely, meaning there will no longer be total solar eclipses on Earth. Also, since the moon stabilizes the Earth's axis, a distant moon could cause more significant variability in our planet's axial tilt. This could have significant consequences for Earth's climate. Axial tilt variation can lead to more extreme seasonal changes and unpredictable weather conditions. This, in turn, could impact agriculture, biodiversity, and the availability of natural resources. In addition, if the moon moves away, it would also affect the intensity of the tides. The moon's gravity is responsible for most of the tides on Earth, and a more distant moon would have less gravitational influence on the tides. This could impact coastal ecosystems and marine life that depend on the tides for their survival. However, it is essential to note that 3.8 billion years is an extremely long period, and it is possible that other cosmic events could occur that have an even more significant impact on the moon and Earth. For example, the collision of asteroids or the change in Earth's orbit around the sun could have significant effects on the moon and our planet. How will it affect the length of days and months? It is interesting to delve into the distance at which the moon is currently and at which it will be in 3.8 billion years, considering that it is moving away from Earth at an approximate speed of 3.8 centimeters per year. Currently, the moon is at an average distance of about 384,400 kilometers from Earth. However, around 4.5 billion years ago, when the moon is believed to have formed, it was at a much closer distance, probably around 22,500 kilometers from Earth. As the moon gets further away, its orbital speed slows down, which means it takes longer to complete a full orbit around Earth. This is causing a slowdown in the Earth's rotation and an increase in the length of days. If we continue to project this departure rate into the future, we can estimate that the moon will be at a mean distance of about 452,800 kilometers from Earth in 3.8 billion years. This is over 17% further away than it is now. Although this extra distance may not seem significant to the naked eye, it will have important consequences for Earth, as mentioned above. Also, the moon will continue to move away from Earth in the future, meaning these consequences will only increase over time. It must also be considered that when the moon is far from Earth, it will appear noticeably smaller in the night sky. Its visual appearance will change since our perspective will be different due to its more distant position. However, even though the moon will look smaller in the sky, it will significantly impact Earth. Also, as the moon recedes, the slowdown in Earth's rotation will slow down even more. This means that the days on Earth will get longer and longer as the moon gets further away. It is estimated that in about 50 million years, days on Earth will be 25 hours long, and within 3.8 billion years, a day on Earth will be approximately 30 hours long. That is longer, 25% longer than the current duration of one day. Can you imagine that? A day with 30 hours? We'll no longer be able to make an excuse that there are not enough hours in the day to do our homework. This slowdown in Earth's rotation can also impact Earth's climate. As the length of the day changes, weather patterns can change, which could have consequences for biodiversity and agriculture. But that's not all. Since when the moon is at a much greater distance than it is at present, it will take longer to go around the Earth. That is, the duration of the lunar month will be much greater than it is now. Currently, the moon's orbital period around Earth is about 27.3 days, but as the moon gets further away, the orbital period will increase. The moon's orbital speed is about 1 kilometer per second, but its orbital speed will decrease as it gets further away. According to current calculations, in 3.8 billion years, the moon will take around 47 days to complete one revolution around the Earth. In simple words, the months will last 47 days and the days 30 hours. We won't run out of moon. it is doubtful that the Earth will run out of moon as it recedes. The moon will gradually move away from Earth, but its departure speed is relatively slow. According to current calculations, the moon will continue to recede from Earth for about 50 billion years. That is to say, much after that the sun becomes a red giant and destroys the entire inner solar system. Also, the moon's orbital distance will gradually increase as it moves further from Earth. But this does not mean that the moon will move further out of Earth's gravitational reach. The moon will always be under the Earth's gravitational influence, even if the distance between the two celestial bodies increases. The fact that the moon is moving away from Earth does not necessarily present a problem for future missions to the moon, or for establishing a base on the moon. Although the distance between Earth and the moon is increasing, the moon will still be relatively close to Earth in astronomical terms. The average distance between the Earth and the moon is approximately 384,400 kilometers. As the moon moves further from Earth, this distance will increase slightly. In 3.8 billion years, the average distance between the Earth and the moon will be about 470,000 kilometers, slightly more than the current distance. Additionally, the moon's gravitational influence does not directly affect missions to the moon and lunar bases. Instead, the distance between the Earth and the moon determines the amount of energy needed to get to the moon and back to Earth. As the moon recedes, missions to the moon will require some extra energy to reach it, but they won't be impossible. The study of the movement and influence of the moon on Earth is a fascinating topic that allows us to better understand our universe and our existence in it. As the moon continues to move away from Earth, our planet and solar system will experience significant changes in the distant future. The days will be longer, the tides will be weaker, and the appearance of the moon will be completely different. However, this natural evolution also reminds us of valuing and protecting our planet and its environment, as they are essential for balance and life in our world. Furthermore, it challenges us to continue exploring and learning about the universe around us to understand better our place in it and our impact in the future. The moon and its influence on Earth reminds us of the incredible complexity and beauty of the universe, and the need to maintain scientific curiosity and a sense of wonder as we continue to explore and discover our world and the universe.